welcome back to another My Tutor online school tutorial. Today it's GCSE Maths, circles and tangents. So this is kind of a higher level lesson today. So this session is 1 hour long, so it will finish at 3 p.m. And I'll have 15 minutes at the end for a Q&A, or if there aren't any, I'll just carry on as normal. So this is me, Molly. I'll be leading this session today. I think most of you have probably come to previous ones, so you probably know me by now. But I study computer science and maths at the University of Bath, and I've now done over 200 lessons with my tutor. So hopefully that means I know what I'm doing. As always throughout the session, use the Q&A and the chat functions on Zoom to ask me questions, just kind of little things. If you spot that either I've made a mistake or you want me to re-explain something, try explaining it in a different way, anything like that, just let me know. And yeah, like I said at the end, I'll have 15 minutes for going over some bigger questions or asking you guys what things from today you want to go over again. So hopefully it should be a good lesson. So let's see, am I good to start? I think so. So today we're going to be covering circles and tangents, as I said. So we're going to start off by looking at the equation of a circle and what that looks like. And how we can tell from the equation of a circle the length of the so what the radius is and stuff like that. And also sketching them from an equation and finding the equation from a sketch. And then we'll have a look into some quite difficult questions about finding a tangent to a circle. So I'll explain what that is, the process of how we find it, and go through loads of exam questions. So hopefully by the end of this lesson, you'll know loads of stuff about the equations of circles. So we'll get straight into it. So, and I was going to get up Desmos for this to show you rather than trying to draw it myself. So the generic equation of a circle looks like this. X squared plus y squared equals r squared, where r is the radius. So if we have a go at putting something into Desmos here, let's say x squared plus y squared equals, well, let's say 9. Because this will have a radius of 3, because 3 squared is equal to 9. And we can see here, also these always have centered the origin. I will go over later what they look like when they're centered somewhere different, but I think that in GCSE you only deal with ones that are centered the origin. So we can see here the center is here, and it's got a radius of 3, because this point here, from 0 to -3, from 0 to 3, 0 to 3, 0 to -3, you can see that it stretches out and has a radius of 3 in all directions. And any point kind of along here, even like this will also have a radius of 3 from like the origin to any of these points on here. So that's the generic equation of a circle, and we can see if we change this, say we want it to go out to 4 instead, we have to make this equal 16, because that's what 4 squared is. And you see now it goes out to 4 on all of the axes. If we make it 36, hopefully you can guess where it's going to go. Up to 6, because that's what 6 squared is. We can have this equaling different numbers that aren't square numbers, but the radius then is kind of an irrational number. So here the radius is root 30. So it can be difficult to tell. So let's have a quick look at what's, I'll stay on Desmos so that we can use it. But we'll have a look at some of these. For example, if we had a question like this that just says, a circle has equation this. What's the length of its radius? Well, all you have to spot is that this is going to be that r squared, so r equals 2. So the radius is 2. And hopefully you can see that. Yeah, and people getting that on the chat. That's the other thing, especially once we get to some longer questions, I'll do what I did yesterday and kind of leave a minute or so for you guys to pop your answers on the chat to make it a bit more interactive and so that you guys are doing something. So that's all there is to it to the equation of a circle. It's nothing too confusing. Hopefully that kind of makes sense as to why that is. So I think, yeah, I think I will, oh, let's have a go at this one actually. And then I'll go over what they look like when they're not centered at the origin. As I said, I don't think you actually need to know that until A level, but I think it's a really useful thing to know just in case, and maybe for some exam boards you do. But we'll start off with this. So here we've got a circle centered at the origin. So that means we already know that this is going to be in the form x squared plus y squared equals r squared, where r is the radius. And we know that the circumference of the circle is 20 pi. So we want to find what the equation of the circle is. Someone's already asked if there's a maths joke. There will be at the end. I've already got one for today. So what do we need to find the equation of a circle? All we need to know is the radius and the origin. We've been told that the origin is the origin. The center is the origin. So we just need to find the radius. So we've been given the circumference, and we normally find the circumference by doing pi d, right? Pi times the diameter. So here the circumference is 20 pi. So our circumference, pi d, is 20 pi. And if we divide both sides by pi, we can see that the diameter is 20. And that means that the radius, because if you remember in a circle, the diameter means from one point, straight line across, and a radius is just to the center. So the radius is half of the diameter, meaning our radius is 10. So what do you think the equation of the circle is? Pop it on the chat or the Q&A. At least one person's got it already. Don't worry if you don't know. As I said, this very early on in the session. So for the equation, all we do, so we know that the radius is 10. So we literally just plug that into our general formula. X squared plus y squared equals r squared. So x squared plus y squared equals the radius squared. So I've written 100 here, oops, because that's 10 squared. So hopefully that makes sense. So you've got to make sure that you square this. That's the one thing that I always used to forget. So really try to keep that in your head. Maybe at the beginning of a circle equation question, write x squared plus y squared equals r squared at the top so that you have something to come back to. Somebody said, could we have written 10 squared? Yeah, I think you could. I don't think you'd be deducted marks for that. I think you could write it as 10 squared. As long as you do write 10 squared and not just 10, that would be fine. So let's try another question that's like that. So let's say a circle with center the origin has radius 8 pi. I don't know how to do the pi sign, so we can just write it there. Sorry, not radius 8 pi, circumference. What is the equation of the circle? So I'll give you guys just a minute or so to see if you can get this one. Yeah, brilliant. Somebody's already got it, which is really, really fab. Just pop it in the chat, as I said, or the Q&A. In fact, 2 people have already got it. Okay, so a couple of people are close, but not quite. So when I explain it, I'll explain where that bit went wrong. So the bit that we have to square is the radius, not the diameter. So yeah, I think people are correcting themselves now. So again, the first thing that we think is that we want the equation of a circle. So we need the center and the radius. That's the first thing to always kind of think. If you're asked to find the equation of a circle, we think, what's the center, what's the radius? Well, we've been given that the center is the origin, which is good. That just means it's x squared plus y squared equals r squared. So now we need to find the radius. So we'll think, well, the circumference is pi d, and that's 8 pi. So dividing by pi here gives us that the diameter is 8. But that's not what you want to square to make the equation. So it's not going to be 64. We want to square the radius. So if you remember, if we have a circle with this as the center, this is the diameter. So from one side to the other, passing through the center, this is the radius, just from the edge to the center. So the radius is half of what the diameter is. So that means that the radius is 4. So that means that when we put it in our circle equation, x squared plus y squared equals r squared, we get x squared plus y squared equals 16. Which a lot of you got, which is really, really good. So I hope that makes sense. Okie doke. So now I'll briefly go through what it looks like when the center is not the origin. So what that looks like is, I'll just do it with an example, I think. All it is that you write our x and our y coordinates minus what the points are. So for example, x minus 2 squared plus y minus 3 squared equals 16 means that it still has a radius of 4. It still equals r squared. But what this means is that the center is 2, 3. So you just subtract, so that it's the x subtract the x coordinate of the center and the y subtract the y coordinate of the center. So if we draw this, just to kind of prove it, so that's what it looks like when it's centered at 4. If we have x minus 2 squared and y minus 3 squared, we can see here that the center is this point here, which is 2, 3. I mean, you can't, it doesn't actually tell us on Desmos, but you can tell that's going to be the center of the circle. And the radius is still 4 if we go from the center and count 1, 2, 3, 4 out. That's what that is. So hopefully that makes sense. Yeah, I think that knowing that it's not the center is A-level, but I just wanted to explain because so that you know why it's always center the origin. I think it's a shame that that's not taught at GCSE because I think it can make it actually less confusing if you know why it's always center the origin. I always hated just being told information with no explanation for it. Someone's also asked, how did you get 4? That's because this one, 16 is the radius squared. So the radius must be 4. 4 squared gives us 16. So as I said, you won't need to work with circles of a different center until A-level. So for the rest of this lesson, we will just be working with center the origin. But hopefully you can see that when the center is the origin, it's the same as calling these points 0, right? X minus 0, y minus 0. And that's just like saying X and Y. So hopefully that gives you a bit more information as to why the center is actually the origin. Yeah, and I think hopefully that makes sense. Someone's asked on the Q&A, which is really good. At the end, can we do a quiz or something like that? That's a really, really good suggestion and something that I'm hoping to implement next week. So I haven't prepared anything like that for today. I normally just do it through giving you some time to answer. But for next week, I'm going to start making some quizzes that I'll do at the end. So thank you very much for the suggestion. I'll definitely get that done for next week's lessons. So I think that's all of the questions about this. Yeah, as I said, we'll just be working with one center the origin. So center 0, 0. But that's just to let you know why the center is the origin. So now we're going to have a look at ones like this, where we have to work out what the tangent is. So I'm going to start on another sheet. Yeah, here we go. So something like this. So find the equation of the tangent to x squared plus y squared equals 45 at the point minus 3, 6. So let's think about what that means for a moment. So this will have a radius of root 45, which is 6.7-ish. We can work that out. At the point minus 3, 6. So let's think about what that means. So let's draw that circle out. So x squared plus y squared equals 45. So yeah, let's see what this actually is. It's there we go. 6.7. That was pretty good. Yeah, about 6.7. And we want to look at the tangent to the circle at the point minus 3, 6. So that's the point. Let me just paste this on. So we want to find the tangent at the point minus 3, 6. So at this point here. So this is actually a point on the circle, which we can tell because x squared plus y squared has to equal 45. Minus 3 squared is 9. 6 squared is 36. Add them together, it does equal 45. So minus 3, 6, as we've seen on here, is a point on this circle, which is good. Otherwise, we couldn't find the tangent at that point. And what the tangent is it's a strange concept. It's a line that only touches the circle at one point. So it's a line like, it's going to be quite difficult to do. A line like this. So it literally just like skims it at that one point. So there's only one straight line where that's true for each point, that it only touches it at that one point. It's kind of, if you zoom in and zoom in, it will look, if you like zoomed in loads, this was the circle, it would look more and more like this, like you could see exactly where it was touching it. It's a difficult concept to explain, but hopefully you'll get used to it as we do more work. So hopefully that makes sense as to what a tangent is. Let me know throughout if you don't get it. So we want to find the equation of this line. So basically it's saying find the equation of the line that just touches this circle at that one point. So we want to know what line that is that does that. So it's a really interesting way that we do this. And we have to use something from a circle theorem. Now, I will be going over all of the circle theorems next week. But for now, I'm just going to tell you this one that you need to know. So what this circle theorem says is that, oh gosh, trying to draw a circle, not working. There we go. If you have a tangent to a circle, and then we've got the center of the circle and a radius, then what the circle theorem tells us is that the tangent meets the radius at a right angle. So at this point here. So if we have a point and we draw a radius and a tangent, they're perpendicular to each other. They're at right angles. And hopefully you can see that from that drawing there, hopefully. So that's exactly what we're going to do here. So we're going to think about the radius from this point, because we can work out what the gradient of that radius is. And from that, we can work out the gradient of a line that's perpendicular using what we've done before, and I'll go over it when we cover it. So the first thing to do is to find out the gradient of this specific radius. And the way that we're going to do that is by doing something. So when we covered graphs, maybe last week or the week before, we talked about how to find the gradient between 2 points. So the first part of this question is basically find the gradient between minus 3, 6, that point on the circle, the point that we're looking at, and the origin. And the way that we do this, if you remember, is we look at the change in y over the change in x. So we take the y value here. so the change in y from 6 to 0 is 6. And the change in x from this one to this one is -3 to 0. So it's -3, -0. So this is just the generic, it's basically like our drawing of a triangle, right? It's kind of like saying, if we want to find the gradient of this, we draw a line here. We see that this is 6 units, this is 3. So we do y over x. It's the same thing, it's just doing it without sketching the triangle, because you can see that you won't always get the triangle. This question doesn't give you any sketch. We did that ourselves. So this gives us 6 divided by -3, which is -2. So what that means is that the gradient of this black line here, this radius, the gradient of that is -2. Now, the way that you find the gradient of a line perpendicular is that the gradients multiply to make -1. And if you did come to the graph sessions that we did, you'll remember that a quick way of doing that is flipping it and making it negative, or adding a minus sign. So if we have, for example, 4/5, and we want to find the gradient of a line is 4/5, we want to find the gradient of a line that's perpendicular, you flip it and add a minus sign. So hopefully that makes sense. So what we're going to do with this one is we'll write it as -2/1, because you can't flip something unless it's as a fraction, and a whole number is just that number over 1. So what we do is we flip it and we add a minus sign, but adding a minus sign to a negative makes it positive. So the gradient of something perpendicular to a gradient of -2 is 1/2. Hopefully that makes sense. Yeah, I think a couple of people are a bit confused by this. I'm going to do loads of examples because this is there's a lot to unpack in it, but they're really, I promise you that they're not too bad once we go over it. So I'll finish this one and then I'll do another example a lot slower. So what we found out there is that the gradient of this line, this tangent, is 1/2, basically. That's what all of that working out was to find. So this has a gradient of 1/2. And then we want to use, again, if you came to the graph sessions, you'll remember this one. So y minus y1 equals mx minus x1. So this is my favorite graph equation, because what this does is you have a point, x1, y1, on a line, and the gradient of the line. You plug it into this, and it gives you the equation of the line. So that's what we're going to use here. So we've got a point, we've got the gradient of the line, 1/2, so that's m is 1/2, and our point on the line is -3/6, because it's the gradient at that point. This is our focal point in this, that's the key point that we're really looking at. So then we just plug it into here. So we have y minus y1, so I've just taken the y value from our point, equals m, so 1/2, x minus x1. So I've just taken the x value from our point. So then we just have to simplify this. Y minus 6 equals, well, I'll start off by saying that -3 is just +3. Then what I'm going to do is multiply everything up by 2. That's because we don't really like having fractions in it to start with, at least. So we'll multiply up by 2 to try to make this easier for ourselves. So when we multiply up by 2, that means that everything on this side is multiplied by 2, so 2y and a -12. And then the 2 disappears from here, so we just get one lot of this bracket. So we just get the bracket itself. Then we just want it in the form y equals mx plus c. So this is a very valid format for the equation, but we're going to have it in the form y equals mx plus c because that's the form that we wanted in. So we have 2y equals x plus 15. And then finally divide through by that 2 again. So y equals 1/2 x plus 15 over 2. And I think someone actually got that earlier. Have I done that? Someone said, where did you get 4 over 5 from? That's unrelated to the question, just to show you about the flipping and adding the minus sign when you're talking about perpendicular lines. Yeah, a couple of people got that before I finished going through it, so well done. This is really difficult. This is like level 8, maybe even level 9 stuff. But I'm really confident that everybody here can follow it because it's using all stuff that we've done before. You know, finding a gradient between 2 points. If you break it down, each step itself isn't too complicated. Let's think about what we did. We found the gradient between 2 points, found the gradient of a line perpendicular, and used our equation formula. We just did those 3 things, and those are 3 things that we've done before. So I'm really confident that with another couple of examples, everybody can be understanding this. And like rewatch the video if you need to. The next example I'll do a lot slower. So yeah. Someone said, what does gradient mean? That's a really good question. So the gradient is all talking about the slope of the line. So and this one has a negative gradient because it's going that way. Anything this way has a positive gradient. If it's a big number, it's got a really steep gradient. And a smaller number, like 1/2, has quite a shallow gradient. And all it is, it's the change in y over the change in x. So a gradient of 2 means that if you go 1 unit in the x direction, you go 2 units in the y. A gradient of 5 means that if you go 1 unit in the x direction, you go 5 in the y. So the gradient just tells us about the slope. Does it look like this or this, this, or this, and so on. So I'm going to do another example really, really similar to that. Literally almost identical, just with different circle and a different point that we're looking for the tangent at. So I'll do this one with a diagram again. And I'm going to try to go over this one really, really slowly. So the question is to find the equation of the tangent to our circle. And we can tell it's a circle because of the format that it's in. X squared plus y squared equals 113. So that's just the equation of our circle. And we want to find the equation of the tangent to that at the point -8, -7. So normally we won't do a sketch for these, but for this one I will, then for the next one I won't. So here's what we're going to do. Let's have a look at what that looks like. So it looks like this. Exactly what we were expecting, center at the origin, and our it goes up to 100, like root 113, which happens to be about 10.63. So this is what our circle looks like. Now we're looking for the tangent at the point -8, -7. So let's have a look at where that point is. -8, -7. So that's here. And again, that's on the curve. We can check that it's on the curve because x squared plus y squared has to equal 113 for it to be on this curve. We've got our x and our y. So x squared is 64, y squared is 49, and if you add those together, you get 113. So it has to be on the curve. To find a tangent, it has to be on the curve anyway. Somebody said in the exam will we be given the picture? Not always. You might just get a question as it's shown on here with no picture. And I will do another one and prove to you that you don't need the picture to be able to do it. If you want to, feel free to do a sketch. You don't have to have a scale at all. Your sketch can literally just look like this. Be like, right, here are my axes, here's my circle, -8, -7 is about there, and I'm looking for the equation of this tangent. If that helps make it clearer in your head, absolutely go for it. And I might even do that for the other ones. I would always encourage, if you're not sure where to go, start with a sketch. So as we can see from that sketch that I just did, the tangent to this looks like this. Oh gosh, it's very difficult to do. Something a bit like that. So it just touches the circle at that one point, which I think is a really weird concept to actually think about, something only touching a circle at one point. You've just got to imagine zooming in, and there's like one kind of tiny little atom that just touches it. Tangents are a very strange concept, but again, hopefully the more we do, the more sense it will start to make. So this is all this question is asking, is for what's the equation of this green line? So we can know roughly what we're expecting. We're expecting something with a negative gradient. So y equals maybe minus 2x, or y equals minus 2/3 x, or as long as it's y equals minus something x, that's what we're expecting. And it looks like it's going to cut the y-axis at about minus 17. So minus 10, minus 12, minus 14, minus 16, a bit further down. So we're looking for something along the lines of y equals minus something x minus 17. So that's the other good thing that a sketch can give you, is it can let you know whether or not your answer is sensible or not. So also someone's just asked, could you show us how to work it out with another method? That's a good question, actually, because I know that I always try to show multiple methods where possible. I'm not actually sure that you can do this using any other method, because to work out the equation of a line, you always need a point that it passes through and its gradient. And I think the only way to find the gradient of this is by finding the gradient of the radius. So unfortunately, I don't think. So someone said you can use y equals mx plus c instead of the straight line equation. You can only use that if you know what the y-intercept is, though. So you can't just straight away use that for this, unfortunately. Okay, if you know how you could use that to... Oh, okay, I see what you mean. Okay, I'll show you that method for now, for this one then. Okay, I understand what you mean. I don't want to over confuse people, but I'll try doing it that method. So it starts exactly the same. You still have to find the gradient. But are you saying sub in the coordinates to find C? I think that's what you're saying. So I'll give that a go this time. So the main kind of point of this is that we're finding the equation of a line. So we need to know the gradient first. We always need the gradient to find the equation of a line. And the only chance we've got of finding the gradient of this is by working off the gradient of the radius. Now this comes from a circle theorem, the one that I was explaining here. As I said, we'll be going over these more next week. Ooh. But if we just look at this here, so ignore everything else, just look at this diagram. All this theorem says is that where the tangent meets the radius, it's a right angle. That's all this is really saying. So tangent, radius, right angle. So we can use that to our advantage, because right angle, perpendicular, they mean the same thing. So this is going to be a right angle. So if we can work out the gradient of the radius, we can work out the gradient of this line. And then we're almost there to finding it. So let's work out what the gradient of the radius is. Well, this radius goes from the origin, 0, 0, to the point that we're looking at, -8, -7. So if we want to find the gradient between our points, let's do -8, -7, and 0, 0. To find the gradient between 2 points, all you do is you do the change in y divided by the change in x. So we're basically thinking, what's the change in y? What's this side of the triangle going to be? Well, if we think about it like this, it's like from 0 down, so it's like 7 down, 8 across. The formal way that we write that, just to make sure that we get the sign correct, is that we do this. So I'll write it down and then explain it. So what this is we take the y value from this one and subtract the y value from this one. So that's the change in y, and then we put that over the change in x. So the x value of this one minus the x value of this one. As long as you like start from the same coordinate and always subtract the other one, you'll get the right solution. So this is really nice for circles because you're always subtracting 0. So all you're really doing is saying this over this because you're just subtracting 0. So the gradient is actually really nice to work out for the radius. So -7 over -8, well, a negative divided by a negative is a positive. So the gradient of this radius is 7/8. So we can write that on. So m, that's just the letter always used for the gradient, is 7/8 for the radius. So what do people think the gradient of this green line is then? Remember, it's perpendicular to this blue one. I'll just give you a little bit of time to think about it. Pop your answers in the chat. Someone's confused about this, saying that I've said that -7 minus 0 equals 7. I've said -7 minus 0 is -7, but then because it's minus over a -8, it's -7 over -8, which is the same as 7 over 8. Yeah, a couple of people have tried the answer in the chat, which is really good. So what we do when it's perpendicular is, and I'll write this here. So I'll explain what we do and then give you another chance to pop it on the chat. So we take what we have. So say the gradient of a line is 2 over 3. If we want to find the gradient of a perpendicular line, we flip it and add a minus sign. So flip it, add a minus sign. If it's 4 over 9, flip it, add a minus sign. So in this case, our gradient is 7 over 8. So have another go at what you think. Yeah, another person's got it now, which is really good. If you do know what it is, do pop it on the chat because it lets me know that you guys are following. Yeah, brilliant. A couple more people are getting it now. Fantastic. So what this will be is we do exactly the same as we just did with the others. We take 7 over 8, flip it, and add a minus. So the gradient of this line is -8 over 7. So we've taken 7 over 8, flipped it, and added a minus sign. So that's what the gradient of this one is. So now we've got the gradient, there are a couple of ways that we can find the equation. So I'll do the one that somebody suggested in the chat first. So this one is that we know the equation is going to be in the form. So we need all these pieces of information for all of these methods. First piece of information, we know the line's going to be in this form. And the reason is because that's what every straight line looks like. Every straight line can be written in this form. The other piece of information that we know is that the gradient is -8 over 7. And the final piece of information that we know is that it passes through our point here, so -8 minus 7. So this is everything we know about this line, right? We know the gradient of it because we've just found that out by looking at the gradient of the radius. We know a point that it passes through. That's just told to us in the question because it's the tangent at that point. So it touches that point there. And we know that because it's a straight line, it can be written like this if we wanted to. So there are now a couple of ways that we can do this. So the one that somebody suggested in the chat, and maybe this will be easier to you guys, is that we basically just want to work out what C is. So the way that we do this is we substitute in everything. So we know that it's going to look like y equals -8 over 7x plus c, because that's what this m means. In y equals mx plus c, m represents the gradient. So we just want to know what the plus c is. And we can do that by substituting in this point here. So when the x value is -8, the y value is -7. So we can substitute that in. So all I've done here is I've replaced y with -7, and I've replaced x with -8. I've kept everything else exactly the same. But now you see, the only thing that we don't know is c. So we can work out everything else and then work out what c is. So let's start off by simplifying this bit here. So -7 equals, well, -8/7 times -8 is 64/7. So the only reason that I don't like this method is I think you can get a bit mixed up with the fractions. I can, at least, anyway. So I'm going to start by multiplying everything up by 7 now to get rid of the horrible fraction that I have here. So -49 equals 64 plus c. And then c is going to be this minus this. Right, so I'm just getting c by itself on this side. So we have -49 minus 49 minus 64 minus 113. So c equals -113. I just want to, oh, sorry, plus 7c. I needed to times everything by 7. My apologies. So see, when I multiplied up by the 7, I accidentally didn't multiply the c by 7. So 7c equals 113. So c equals minus 113 divided by 7, which doesn't give us anything nice, so we'll just keep it written like that. So that means that we can write our equation instead as y equals -8/7x minus 113/7. And there's our equation. And we did that just by knowing these 3 facts in black at the top there. Yeah, someone said, what an ugly equation. Agreed. That is kind of a horrible equation. Does that one make sense to people, or would you like me to go through the other method? So everything's the same just up to this point. There's just another equation that we can substitute stuff into. It's essentially the same thing, but if you want me to go through it, I will. So just let me know whether you want me to or not. Someone's asked which one is faster / easier. That's a very good question. I'd say they're both the same. They are pretty much both the same equation, kind of like the same method, just slightly rearranged. So I guess they're both the same. It's just which one. It's understandable. No one's really said anything, so I'll assume you're fine and you don't want me to explain it the other way. But do correct me if I'm wrong. So what I'm going to do now is I'm going to go through another question that's like exactly the same, just with different numbers, because I think it's really important to see loads of examples and see that they are exactly the same every time. So whilst I'm doing this, let me know any questions that you have, maybe about anything that we've been through. So just say, oh, how did you get this when we did that question? Or let me know if you want me to go back to the first one, so what the equation of a circle means. Like, let me know if you want me to go back to anything. If I don't get anything, I'll carry on with questions like this. But just let me know in the chat or the Q&A. So whilst you're doing that, I will go through this one here, which looks awful. So this will be fun. So find the equation of the tangent to that at the point 2√5 minus √30. So I'm not going to draw this one out. I'm just going to do a very quick sketch. So we know that a circle looks like this, and these points here will all be whatever √50 is. At the point 2 root 5 minus root 30. So I'm just going to put that somewhere. We know that it's in this quadrant because it's positive x, negative y. And we want to find the tangent. So that's just a very quick sketch. We're looking for the equation of that blue line. So we're looking for something that's got a positive gradient and a negative y-intercept. That's all we can really tell just from that sketch. So let's have a look. Do not be thrown off by the fact that they're roots. These have been thrown in order to make you scared of it. I will hopefully show you that it's exactly the same as all the other ones that we've done. So the first thing that we're going to have a look at, remember, if you need kind of a quick thing to remember, I guess it's 1, gradient of radius, 2, gradient of line, 3, equation of line. I guess this is just the thing to remember. Whenever you have a question like this, it's these same 3 steps every time. So first things first, gradient of the radius up to this point. So remember, that's the gradient between the points, or the one that we have. Oh, sorry, I don't know why I did a comma there. 2 root 5, root 30, and 0, 0. Oh, minus root 30. So the gradient will be change in y over change in x, which is equal to minus root 30 over 2 root 5. And I think we could simplify that using surds. Yeah, we can. So the reason that I'm going to simplify this is to make it easier for us later down the line. So I've covered surds by this before. I'm pretty sure I've covered surds before. I get confused as to what I've covered in this and what I've covered in private lessons. Yes, no, I have done a lesson on surds. So check out the My Tutor YouTube channel. These are all recorded and put on there. I think the topic was called powers and roots or something. And the second half of that lesson was about surds. So yeah, check out that. The only thing I'm going to do here is the rule that if you have a root and you divide it by something else, it's the same as dividing within that root. So this is the same as so root 30 over root 5 is the same as root 6, because that's what 30 divided by 5 is. So all I'm saying is that this is equivalent to this. So all I've done there is I've divided the top and the bottom by root 5, essentially, to simplify it. Hopefully you can see that. So minus root 30 divided by root 5 just gives us minus root 6. That's what I just explained. That's just a surd law. And then 2 root 5, when you divide that by root 5, you just get 2. So the gradient of the radius, so we've done this step now. Step 1 done. Gradient of the radius is minus root 6 over 2. Step 2 is super easy. Going from the gradient of the radius to the gradient of the line. Remember, these are perpendicular. So all we have to do is flip it and change. Pop it in the chat. While you're doing that, someone said, what is a surd? A square root. That's what it is. So root 30 is a surd, root 5 is a surd, so on. It's just a scary extra word for a square root. So yeah, if the gradient of the radius is minus root 6 over 2, what do you think this is? Someone's given it a go, really, really close. Remember that if it's already negative, when you flip and add a minus, it actually makes it positive. Yeah, brilliant. Okay, good to see that people are giving it a go. So what this will be is 2 over root 6. So a few people said minus 2 over root 6. That's really, really close. But you've got to flip it. And adding a minus to something that already has a minus makes it positive. So maybe it's better to think about it as flip it and change the sign. Maybe that's a better way of thinking about it. So if it's already negative, make it positive. Yeah, quite a few people got that, which is fantastic. So that's step 2 done. That's a super simple step because you just flip it, change the sign. So we found the gradient of the radius, which has helped us to find the gradient of the line. And then step 3 is to just find the equation of the line. So for this one, I'm going to do the original method that I did, which is using y minus y1 equals mx minus x1. So again, let me know if you don't understand this equation. All it is you have a gradient m and a point on the line, x1, y1. Throw all of those numbers into this and it gives you the equation. So what we know is that we've got our gradient here and our point here. And that's all we need to fill in this. So I'll show you. Y minus root 30. So what I've done there is I've done y minus y1, and y1 is just the y coordinate of the point that it goes through, equals m. Well, m is 2 over root 6. See, this is our gradient. X minus x1. So x minus, and then this is x1. Right, it's just the x coordinate. That's all x1 and y1 are. They're just the x and y values of whatever the coordinate is that it passes through. So we end up with this horrible looking thing. Now this kind of is already the solution. All we're going to do is put it in a much nicer form. But if you've understood it up to here, you have essentially done the whole question. All I'm going to do now is rearranging just to make it a more understandable form. So I'm going to start by just making this left-hand side y plus root 30. Because we've got a negative, negative, so that becomes a positive. That's all I've done. Haven't changed the right-hand side. Then what I'm going to do is we're going to multiply everything by root 6. And the reason for that is because basically we don't want to work with that fraction. If we've got fractions and surds in one thing, that is too much to handle. So we're just going to multiply everything up by root 6. So I'm actually going to keep this as root 6 times root 30 because we are going to redivide it soon. So hopefully you can see how I did that stage. All I've done is multiply both of these bits by root 6, and then multiplying it here gets rid of it. Then I expand out the right-hand side. So this side stays exactly the same, nothing to see here. And then on the right-hand side, we get 2x and 4 root 5. So I've just multiplied this by 2, and I've multiplied this by 2. Again, that's just basic expansion. Then we want to, this is the bit that's going to be difficult. We want to get rid of this. So actually, I guess I will write this as, so this is a similar surd law as before. If you have, say, root 2 times root 3, that's the same as saying root 6. So just like with the division, you can combine them. So this is the same thing as saying root 180. Hopefully that makes sense. I think the rearranging of this is actually the hardest bit. Yeah, someone said, would it be easier to not simplify the surds when using the straight line equation? Yeah, quite possibly. It could be easier just to leave it like this. It depends what the question's asking for. So again, if you're not following this bit, don't worry. The only reason I'm showing you this is just in case the question specifically said, give it in the form y equals mx plus c or something like that. So then we'll subtract that from both sides. So here's the difficult part. We want to do minus 4 root 5. I'm actually going to do this on I'll do it just in this little bit over here. We want to do minus 4 root 5 minus root 180. We're just going to do a simple trick. We're just going to write this as something in terms of root 5. In fact, this is just going to be, I'm actually not going to simplify it because it's going to be more trouble than it's worth. That's much more of a surds question, actually. So I'm just going to keep this as written like this because it doesn't really matter. And in fact, we'll, oh, sorry. Oops. Oh my gosh, I'm trying to undo. There we go. Sorry, I meant that to be root 5. And then divide through by root 6. And the good thing is that we get this bit, which is good. That's what we expected the gradient to be. And then this horrible load of rubbish. So whoever said it would be nicer not to simplify was definitely correct. I would say it's a lot easier just to leave it in this form here. Both of these answers are perfectly correct, but you're just more likely to make mistakes if you start trying to do this. If that makes sense. So that is a horrible, horrible question. Definitely a okay, sorry, someone said I don't quite understand. It's definitely easier just to leave it in this way here. So we've got 5 minutes left. So someone's asking about private My Tutor lessons. I do offer those, as do a lot of other people. So if you want one-on-one, definitely maybe send an email to My Tutor to ask them. And if you want one specifically with me, just mention my name. I'm sure they can pass it on to me. Yeah, I'll mention that again at the end anyway. It's not quite joke time yet. We're going to go through one more short question before, because we've still got 4 minutes. We don't want to waste that. So what I'm going to do is this one to finish off, because the numbers are a lot nicer. So hopefully you'll get a better idea of the method. Someone said, is this definitely GCSE? Yes. That one with the surds, definitely a level 9. But this is GCSE, because all it is stuff that you know. All we're really doing is equations of circles, and then just straight line graphs is the rest of it. So it's top level, you know, level 8, level 9. But it is definitely GCSE. So many messages about the math joke. It's coming, I promise. We'll just do this question. If you can just focus on this one question, we'll get to the joke at the end. So this is a really similar thing. So I'm going to go through this quite quickly, just as a final challenge kind of one, because we don't have long. So P lies on the circle and has x coordinate 1. The tangent at P intersects the x-axis at Q. So we want to work out the coordinates of Q. So don't worry if you don't follow this one. I'd encourage you to watch it back, you know, to try it after the session. This is similar to the other ones, but we're going to give it a go. So the first thing that we want to know is the full coordinates of P, because without that we can't do much. So we'll just work it out. So when the x value is 1, what's y? So we're just going to substitute it into here. So 1 squared plus y squared equals 10. So y squared equals 9. So y is 3. So the coordinates of P are 1, 3. Now we're going to do step 1, find the gradient of the radius here. So that's the gradient between 1, 3 and 0, 0. So 3 minus 0 over 1 minus 0 is 3 over 1, which is 3. So the gradient of this is 3. So what's the gradient of the tangent? That's step 2. Remember, that's the same as 3 over 1. Flip it and add a minus. So it's got a gradient of minus a third. So then we're going to use y minus y1 equals mx minus x1 to find the equation of this line. So we know that it passes through this point. I'll just circle them in colours. So we know that it passes through this point. Oh my gosh. And it has a gradient of this. So we just fill all of that information in. Someone said, is this the maths joke? So I'm going to multiply everything by 3 to make this nicer to deal with. Then just expand this out by that negative there. Add 9 to both sides. I'm doing this super, super quickly, so definitely watch it back, pause, make sure that you understand each step. But I think it's good to get in one more example. And then divide it by 3. So y equals minus a third x plus 10. So that's the equation. And then we want the coordinates of Q. Well, the coordinates of Q are on the x-axis, and that's where y equals 0. So the coordinates of Q are something 0. So let's work out what this is when y equals 0. So 0 equals minus a third x plus 10. So let's multiply it by 3. we get 0 equals minus x plus 30. So x equals 30. So the coordinates of Q are 30, 0. And that was a 5-mark level 9 question that I just raced through at the end. So definitely, yeah, definitely. I'm just checking that I didn't go wrong anywhere. I don't think I did. So pause, go back through, watch it, pause it. I think this is a past paper question. I'm not sure what from, or it's definitely something that you could get as maybe a final question on a paper. So yeah, makes sense. So it's the end of the lesson. I have not forgotten the math joke. It's happening, I promise. So the math joke for today that somebody sent me is quite relatable. So why couldn't the teacher finish the maths lesson? Because she kept going off on a tangent. There you go. There's the joke today, and it relates to today because not only do I always go off on a tangent, but we were also studying tangents. So, oh gosh, I've got even more jokes coming. Right, we'll do some more next week. Thank you very much for coming today. Well done for keeping up your maths as well. My tutor, we do offer one-on-one tuition, as somebody asked about. I do one-on-one tuition as well. So loads more information about that is on the My Tutor website. They have a really useful feature that helps you find a tutor. Or if you want more information about any of us who do these live sessions, just shoot them an email. The team is super, super useful, and they can help you with any questions that you might have. So make sure to check out the timetable for what we have going on tomorrow, and one should be coming out soon about next week. So again, thank you all for coming. Have a fantastic week, and I'll see you next time. Bye, guys.